Hello, grade 9 learners. Allow me to accompany you in exploring the world of expressions with rational exponents in order to develop the skills in rewriting these kinds of expressions to the radical forms and to learn how to simplify these kinds of expressions. First of all, prepare your learning activity sheets, pens and scrap papers, and glass of water and your snacks, and make yourselves comfortable in your seats. Our lesson for today is about expressions with rational or fractional exponents. At the end of the lesson, you are expected to: number 1, write expressions with rational exponents as radicals and vice versa. Number 2, simplify expressions with rational exponents. Your skills in laws of exponents, radicals, and operations of fractions are highly needed in this lesson. Always seek the assistance of your teacher whenever you encounter difficulties with these lessons. Our first focus will be on rewriting expressions with rational exponents to radical expressions. Rewriting expressions with rational exponents to radical expressions will enable you to simplify radical expressions. So, how do you describe an expression with rational exponent? It is an expression in the form a raised to m over n, where both m and n are integers. M is an integer other than 0, meaning m will never be equal to 0 and n is greater than or equal to 2. On the other hand, radical expression is an expression containing radical with variable or variables in the radicand. In the radical expression, the nth root of a raised to m, n is the index, a is the radicand, and m is the exponent of the radicand. The two statements suggest that a raised to m over n is written as the nth root of a raised to m. Here are some examples of expressions with rational exponents. In writing expressions with rational exponents to its equivalent radical form, number 1, the denominator of the rational or fractional exponent becomes the index. Number 2, the base becomes the radicand. And number 3, the numerator of the rational or fractional exponent becomes the exponent of the radicand. Examples. Number 1, 5 raised to 1/2 to its equivalent radical form is the square root of 5 raised to 1, which in simplified form becomes the square root of 5. And by the way, if the index is 2, you do not need to write it. In the expression, the square root of 5, the index is understood to be 2. Next, number 2, negative x raised to 2/3 becomes negative cube root of x squared. When the index is more than 2, you really need to write it. Third example, the quantity of negative x raised to 2/3 to its equivalent radical form is the cube root of the quantity of negative x raised to 2. Number 4, 2y raised to 3 halves. The exponent 3 halves belongs to y only. Its radical form is 2 the square root of y raised to 3. Number 5, the quantity of 4a raised to 3 over 5 or 3/5. The grouping symbol indicates that both 4 and a are being raised to a power of 3/5. Rewriting it to its equivalent radical expression, it becomes the fifth root of the quantity of 4a raised to 3. Number 6, our last example, negative 3x raised to 1/3. Take note, class, 1/3 is the exponent of x only. In radical form, it is negative 3 the cube root of x. Our next focus will be on simplifying expressions with rational exponents. Let us take a look at the solutions of the examples on pages 2 and 3 of your class. Number 1, simplify 16 raised to 1/2. First, rewrite it into radical expression. 16 raised to 1/2 becomes the square root of 16. Extracting the square root of 16, it is 4. Therefore, the simplified form of 16 raised to 1/2 is 4. Number 2, simplify negative 64 raised to 1/3. Rewriting it in radical form, it becomes the cube root of negative 64. Extract the cube root of negative 64, the answer is negative 4. Thus, the simplified form of negative 64 raised to 1/3 is negative 4. Number 3, simplify the quantity of 9 over 49 raised to 1/2. In radical form, it is the square root of 9 over 49. Separating the numerator and denominator, square root of 9 over the square root of 49. Extracting the square roots of both numerator and denominator, we will arrive at 3 over 7. For numbers 1, 2, and 3, the numerators of the rational exponents are all positive 1, isn't it? It is easier to simplify an expression with rational exponent if the numerator of the exponent is 1 or positive 1. Number 4. What is the simplified form of 16 raised to 3/4 or 3 over 4? Rewriting the expression in the form a raised to m over n equals the quantity of a raised to 1 over n raised to m. It becomes the quantity of 16 raised to 1/4 raised to 3. Rewriting 16 raised to 1/4 in radical form, it becomes the quantity of the fourth root of 16 raised to 3. Extracting the fourth root of 16, we now have 2 raised to 3. Simplifying 2 raised to 3, we have 8. Thus, the simplified form of 16 raised to 3/4 is 8. For number 5, 625 raised to 3/4 becomes the fourth root of 625 raised to 3. Taking the fourth root of 625, it is 5. So, 5 raised to 3 is equal to 125. Therefore, the simplified form of 625 raised to 3/4 is 125. For number 6, the rational exponent is negative. We need to make it positive first before we rewrite it in its equivalent radical form and simplify. 625 raised to negative 1/4 becomes 1 over 625 raised to positive 1/4. Its radical form is 1 over the fourth root of 625. Simplifying it, it becomes 1 over 5 since the fourth root of 625 is 5. Thus, the simplified form of 625 raised to negative 1/4 is 1 over 5. So that's it. I hope you were able to understand these examples. Don't worry, we have additional examples on simplifying expressions with integral exponents. All the laws of exponents and conditions in simplifying expressions with integral exponents are also applicable in simplifying expressions with rational exponents. Here are some examples. First, simplify m raised to 2/3 times m raised to 4/3. Since the operation is multiplication, we need to add their exponents. So, m raised to 2/3 times m raised to 4/3 equals m raised to 2/3 plus 4/3 equals m raised to 6 over 3 equals m raised to 2. Second example, simplify 8x raised to 2/3 over 4x raised to 1/4. The operation is division, so we will subtract the exponents. Since the least common denominator of 3 and 4 is 12, it now becomes, the simplified expression is 2x raised to 5 over 12. Third example, simplify the quantity of r raised to 12, s raised to 9, raised to 1/3. First, multiply the power 1/3 to the powers of r and s. We will have r raised to 12 times 1/3, s raised to 9 times 1/3. Simplifying the outcome, it is now r raised to 12 over 3, s raised to 9 over 3. Dividing the rational exponents, we now have r raised to 4, s raised to 3. Last example, simplify the quantity of x raised to negative 8 over 16y raised to negative 12 raised to 3/4. We will multiply the power 3/4 to the powers of both numerator and denominator. X raised to negative 8 times 3/4 over 16y raised to negative 12 times 3/4. Evaluating the rational exponents, x raised to negative 24 over 4 over 16y raised to negative 36 over 4. Dividing the rational exponents, it becomes x raised to negative 6 over 16y raised to negative 9. The expression will be y raised to 9 over 16x raised to 6. Again, do not hesitate to ask for more clarifications from your teachers. By the way, the answer key was provided for you to counter-check your own answers and not to copy from it. This is Teacher Genevieve Palangdao saying, stay safe and God bless.